So the next stage is to get the uncertainties. Now, really, you should do this halfway through the previous stage and get the error bars on your graph before you do the line of best fit. So realistically, this should be a step that you do halfway through the last one, once you've got to a point of plotting your graph. And before you do this final stage of finding G, you'll find it a good stage to put in. But as long as you apply it at some point, then for now that's okay. But normally, actually, these two things happen simultaneously. Okay, so uncertainties in error bars. Let's start with the uncertainty in T. So this is the error bars for our y-axis direction. Now T comes from our values of 10t, which we took hopefully multiple readings of. You might only have done 2, but you've still got repeat readings in T. So I use the example as if I'd done 3. That means somewhere you've got a mean of 10t, and then somewhere else you've got a value for just t. So this is the mean of the 10t, and this is the value for one single period. So you should have those values calculated somewhere. Now, the error in t, therefore, is as a result of a set of repeat readings. So if you remember, we do repeat readings and the error in the mean of those repeat readings as the standard error. So remember that standard error is standard deviation divided by root n. So what you need to do is work out the standard deviation of those, let's say, 3 repeat readings, or if it's 2, you can still do it for 2. Divide that by, in this case, would be root n. So in this case, it would be root 3. If you've only got 2 repeat readings, you do the standard deviation in the 2. The equation still works. And then divide it by root 2. This is giving you the error in 10t. So it's really important that you realise what it is that you've got there. And that is probably going to get its own column somewhere. The error in 10t. You've calculated a value in the mean of 10t and the actual value in t. And this is the one that you're going to plot. So this value here is the one that goes on the graph as your value for t. So you now need to have another column where you work out the uncertainty in just 1t. Luckily, you've done all the hard work to get this value here using the standard error. This is the standard deviation divided by root n. That's the hard part. This is the easy bit. You've essentially just got to work out what the error in 10t is. Simply divide it by 10. It's not the only way to do it, and it's not the perfect way to do it, but it is probably the most straightforward. If you haven't worked out what this value is, if you've not worked out what this value is here, but you've jumped straight from your 3 values of 10t to a value of t, so you've taken a mean and immediately divided it by 10. That's not a big problem, but you can still go through the errors process and work out the purple column, what the error in 10t is, and then divide that by 10 and work out the final red column. But it is the red column, the one that you want for your y-axis uncertainties. So again, you'd need to do that for every set of repeat readings. So you'd have another value here, another value here, and so on. So for every length, you'll have a set of repeat readings. And each one of those needs to have its uncertainty to give you a y-bar axis. If you can't remember how to work out standard deviations, you can go back and have a quick look at that. Just call up the equation, remember. It's basically the difference between the mean and the value. Square that difference. Divide it by n-1, so the number of repeat readings you've got, minus 1. Square root the whole thing once you've added all of those together and divided by n-1. But go back, I won't explain that here because there's plenty of explanation on that, so I just want to keep the video really, really short.